Hello, everyone. In this video, we are going to talk about the oscilloscope, specifically the model Rigol DS1054. The general oscilloscope would not have much of a difference like the oscilloscope. If you have like another model of the oscilloscope, basically they have like the same functions. It's just a different kind of like representation of different like front panel. Now, let's start with the basics of this device. As you can see, we have several ports. These are the input port. Okay, for example, my oscilloscope has 4 channels. So at the same time, I could have 4 input. So oscilloscope could measure the values and the parameters for those inputs. Okay, and each of those inputs are labeled, like this one is channel 1. And if you want to control the characteristics of the input, the channel 1 here, the bottom label channel 1, would control if the channel 1 is activated and how we can set the settings for this input. Now, generally, the screen, as you can see, have some sort of grid. Okay, the vertical axis is the voltage or the value of basically the parameter you wanted to like measure, and the horizontal axis is the time. Okay, the value, each of these square represent a unit of the value, which we are gonna talk about it later on in this video. The width of each of these square weighted equal to the time division that we are going to set, and the height of each of those square would represent the unit of voltage division is equal to the voltage division as a weight of our measurement. Okay, so for example, if you want to measure a signal and like the value of peak to peak, like the amplitude of that signal occupies 2 square, the value of that peak-to-peak voltage is going to be 2 times whatever voltage division you set. Okay, now you can activate all those channels here, and if you push, like you see, I deactivated channel 1. If you push each of those channels, okay, you can activate each channel, and it would open up a menu here, as you can see, that is the characteristics of our system. Now, one of the option is coupling. With the bottom in front of it, you can control and change it. Okay, so the coupling has 3 options. The DC, if you put it to DC, that means all the components in your signal is going to be displayed, both DC component and AC component. If you put it as AC, which you can choose by simply clicking the same button over and over again, you can change the options. The AC options blocks the DC components and only show you the AC components of your input signal. And the ground option simply connects the input to the ground, so it's only show you a flat 0. Okay, so this is the coupling options. The bandwidth limit in like this model has 2 bandwidth limit. One is off, which if you put that bandwidth limit on off, okay, that means the bandwidth of your measurement is going to be the maximum bandwidth of your oscilloscope. But if you put it in a 20 megahertz, that means your bandwidth is going to be 20 megahertz. Okay, so it's going to be limited to 20. The probes that we are going to use for injecting the input and measuring our parameters would have a certain amplification, so some certain coefficients. You have to define the coefficients here. If you click on that menu, you see you have several options. We normally use either ×1 or ×10 because of the probes that we use in the lab. Okay, so remember, if your probe, we are going to show you, let me actually show you right here. In the probe, you see a knob here. There is a, I hope you can see that value. Here is 10 times, and here is 1 times. So by changing this switch, you can switch the coefficients of whatever signal this probe would measure. Okay, and the measurement is done with these two probes. This one is normally connected to a ground or lower voltage, and this one is the measuring probe, basically. But, and by the way, all the probes are color coded. Okay, so it's the same color code as the channel that you see here. So I strongly encourage you to use the same color for each channel. So if you have several probes connected to your circuit, you know which one is which. Now, so this is the probe coefficient. Okay, the invert menu is simply invert the voltage. So, for example, if you have a sinusoidal voltage, if you turn on the invert option, it simply inverts the positive and negative half cycle. Okay, now we have voltage division, we don't change that. Okay, there is a fine option and there is a curse option. We are going to use curse option. And last option is the unit. Okay, this is mostly for display purposes. So you can change the unit, either it could be watt, amp, volt, or potential. Okay, so this is basically, we are going to use volt in our system. Okay, so we are not going to change that basically. Now, the knob here that you can see is the knob for navigating through each of the menus. So as you can see, if I turn that, I could navigate between the option. Okay, and by pushing it, it works like an enter. So I would select that option. Okay, and if you push any of those channels, they have a specific same specific menu for each of the channels. So you can choose and set the channels independently. Okay, now we said each of these squares have both time division rate and volt division rate. How we can set that? When you choose a channel, okay, with this knob, you can change the volt division. The value of the volt division is mentioned here, is shown here for each of the channels. Okay, so let me activate channel 2. Now you see the channel 2, which is the blue color, showing here. By turning the knob, I can increase the weight of each square, okay, the height of each square, or decrease it. So right now, like I'm putting the voltage division for channel 2 at 1 volt, okay? So this is channel 2 at 1 volt, okay? That means each of these squares, the height of each of these squares was 1 volt, okay? Now, these knobs here changes the position. So it gives you an offset so you can move the signal up and down, okay? If, for example, you wanted to like separate the signal so that the channel 1 and channel 2 or other channels would not overlap, you want to use this for each of them. And if you like press channel 1, you can now move channel 1. Okay, now if you push this knob, it would reset to 0, reset the offset to 0. Okay, now the time division is the other set of the knobs. Okay, so this, if I change the time division, that means the width of each square weight would change. So now, like for example, now I set the time division at 10 microsecond. That means the width of each of the squares is equal to is mean 10 microsecond. The time division is shared between all the channels. So you cannot set the time division differently for different channels. All of them would have the same time division. And this knob would, you can see that because it's a flat zero, but it would shift right and left in time your waveform. You can see that this indicator that is moving left and right. Okay, so basically we are changing the position of our system. And again, if you push it, it would reset to zero. Okay, so this is what we have so far. In the volt division section, we have an option named math. Okay, if you click on that, you would have a menu. The decoding menu, okay, we don't use it, but the math one is very useful. So if you click on the math, now you have several operations. Okay, so now, for example, you can you can do a summation between the signal A and signal B, or have like a minus B, A times B, or divide them, or even run an FFT, the fast Fourier transform, okay, or parallel them. You know what I'm saying? So, or A to the power of B. There's a lot of square root, ln, logarithmic, exponential, all those absolute value, all those math function could be applied to your signal. Now, this is right now, my operation is off. Okay, but I can turn on the operation, and you see this purple one, the purple line. This purple line is the result of operation. So right now I asked for A plus B. So this purple line is A plus B. Now I don't have a signal inputted to the system. So right now you can see anything meaningful. But if you have a signal, that would basically mean something, you know. Next option is defining the signal A and B. What are the signal source of the signal A and B? Right now, my signal A is set on a channel 1. If I click that, I can change it. Okay. Same goes for the source B. If I set that, I can change it. Now, there is an offset that you can set. This is how I toggled this purple line. You see, if I change that purple line, I can change this offset. It would show you what is the offset that you have. So if you wanted to set like a measure of peak value, you know the peak value has a certain amount of offset, okay? And the last one is the scale. That right now, for example, the scale is 100 milliamp. Why? Because the voltage division for my channel 1, which is the source A, is 100 milliamp. Okay, which is the lowest actually voltage division. Okay, so this is how the menu math would work. Come on. Let's do the operation off, and it's off. Okay, now here in the right side of my screen, okay, I see a lot of variables. Okay, these are the measurements that you can make. Okay, like for example, right now, the top one is the max voltage. So if you click on that, this is channel 1 is activated. If you click on that, on the bottom, it would show you the max voltage. Now, the next one is minimum voltage, voltage peak to peak, and for example, bypass voltage, voltage amplitude, and you can have, there is several other options like the lower voltage, the mid voltage, the RMS value, the overshoot value, the area of our signal, the area of each cycle of our signal. Okay, so this is a lot of information measurement that is inserted in this menu that you can choose, and whatever you press, whatever these options you choose, the value would appear on the bottom of the screen. Okay, now we have another option to do the measurement, and this is the bottom title measure. If you click on that button, okay, if you click on the measure button, okay, it opens up a menu. First, for the measurement, you can choose the source. Okay, you change this. So far, my source is channel 1. Okay, let me still stay in channel 1. Now, if there's a counter menu, if I turn on the counter, okay, to channel 1, for example, okay, now I have all the, now it shows how frequent my sampling scale is for doing that measurement. There is a measurement on and off. If I turn it on, okay, now you can see, let me turn off the counter so it would not disrupt the view. Now you can see a lot of parameter, a lot of characteristics of the parameter that I'm measuring in channel 1 would show here. All the yellow values are for channel 1 and the blue one for channel 2. Okay, now how we can add channel 3 and channel 4 or eliminate like channel 2, we have the measuring source. If you click on the measuring source, it gives you the option to choose how many channels you wanted to like have and which one you wanted to include in the measurement. So you have channel 1 to 3 and math. So you can have 5 options at the same time. Now, for example, right now, the source are channel 1 and channel 2. I'm going to eliminate channel 2, go here, push enter. Now see, the blue line is eliminated. Now I have only channel 1 as a source of the measurement. There is a statistic menu, okay? So it basically shows you the measurement based on the time variant measurement, which is based on the statistical values of your signal. Okay, so this is the menu of the measurement button that you can use to have the measurement that you need. Okay, the next option is the cursor. Let me turn off the measurement first. Okay, the cursor, okay, if you turn it on and you put it, it could be on manual or track the signal or auto. Okay, we put it in manual because we normally wanted to like have a control over the cursors. Now you can see we have 2 vertical and 2 horizontal cursor. How we can use it? For example, if you wanted to like measure the difference between 2 points of the voltage or the difference between the 2 time, okay, the duration and the value between the 2 points, each in a voltage and time, you can basically change the position of the cursor and set that between the points that you want, and the value here would show you what's going on in the signal. Now, for example, right now, the cursor is on the vertical one. So if I change, if I turn the signals, turn the knobs, I can change the position of the vertical cursor. I can change it to the horizontal one, and now I can change the position of that horizontal one. There is a source, so right now the source is channel 1. You can change it. The next option show you where is your cursor A. The cursor A is the one that you control here. The cursor B, if you click on that, you also can control the cursor B, which is the cursor A is a solid line, the B is the other one. Okay, so it's like the line that created by the some dashes. Okay, now this is how you can use the cursors in order to measure the difference or the distance between the 2 points, either in time or in the amplitude of voltage. Now, the next option is the display. In the display, you can change the actually it is on the name, the display of how it works. You can use the dots or vector to show the signals. Okay, you can basically change the persistence of the time. Okay, I'm not going to change that. You can choose the intensity. The intensity also can be changed by this knob, simply by turning the knob. You can turn on and off the grid or change the how it will be showed in the circuit, in the screen. Okay, and here you can change the brightness. Okay, so you can change the brightness of your display. Okay, so this is basically the settings for the screen. The next button is the storage button. If you click on that, you can save the data that is shown in your oscilloscope into a thumb drive. Okay, or if you connect this oscilloscope to a computer, you can also choose that computer as a destination of the file. Here is a USB button that you can connect your thumb drives. Okay, you can store either a picture or a wave, or if you want to like have an Excel file, the CSV is where to go. Okay, and for example, if you have a picture, now you can choose the format of that picture, like PNG or JPEG or TIFF system. Okay, and you can add the parameter on and off, so you have all the information too. In the save menu, you can choose either the local disk, which is the internal disk, okay, and it has the 90 megabytes of capacity, or if you have a thumb drive here, you have an option of choosing that thumb drive too. Okay, come on. And this is a disk manage. So basically, if anything you saved in your disk, you can access that. So later on, maybe you wanted to like see whatever you saved in the oscilloscope previously. Here you can choose that and watch that. Okay, so this is the storage menu. The utility menu is the general settings of the oscilloscope. Okay, so like this is the sound on and off. If you click, it would kind of like beep. Okay, we normally set that as off. the language or like the pass fail or the record or the system. These are the general system that you don't change normally when you're working with the oscilloscope. Now, let's talk about the last part that we wanted to like explain for the oscilloscope, which is the trigger menu. Okay, the trigger menu basically is what stabilize your waveform. Okay, without a trigger, basically the scope would just keep redrawing the signal randomly, and you see a mess. Okay, so you can trigger on any of the 4 channels or on the external input. Okay, so it is the option that this oscilloscope gave you. Okay, we have several type of trigger. If you push the menu here, the menu trigger, it would open up the menu. We have several type of trigger. Edge is the common trigger mode, trigger type, and it fires when the signal crosses a certain threshold. Okay, doesn't matter rising or falling. Okay, there are other triggers. Okay, in our lab we use the edge trigger. Okay, so we don't change that. There are other triggers, like for example pulse, which triggers when a pulse is narrower or wider than expected. We have like a runt. Okay, here that let me go to runt. Yeah, the runt, which finds pulses that don't reach the full logic level. Okay, we have the slope. Okay, that triggers based on how fast the signal is rising or falling. Okay, there is video, which locks to the lines in a video signal. We have pattern, uh, which triggers on a logic combination across the channels, or we have timeout here, okay, which basically triggers when a signal is missing for too long. Okay, so there are different type. We normally use the edge, okay, so we don't change that in the lab. Come on, okay. Now, this the second option shows the source of the trigger. Right now, because we only activating 2 channels, okay, we only see channel 1 and channel 2. So this is help you to set the individual trigger mode for or trigger type for each of the channels. Right now we are channel 1, we don't change it, so doesn't matter for us. Next one is the slope. Okay, for the slope, basically it shows you, like for example, it is in the edge. Okay, the slope shows you that you want to like do that based on the rising edge or falling edge or mix. Okay, again, we don't change that. There is a sweep, which we normally put it in the auto. Okay, but there is also some buttons here that relates to the same modes of triggering: auto, normal, and single. The normal is also labeled as run stop. Okay, in auto, if you push the auto, it would automatically detect the signal characteristics and change the triggering based on that. Okay, in the normal is just show you in the normal trigger, it just show you in auto, it just show you the normal situation in your system. Like normal basically waits for a valid trigger, uh, great for like a stable viewing. Okay, and when you set it to the single settings, okay, it captures just once and it stops. So if you want to have a solid non-changing view of your signal, you press single. Okay, you press single. So this is how you can choose your trigger. You don't change. This is the coupling. You don't change the coupling. we want to have a DC coupling, so we have everything. There is a hold off. Again, you don't change it. One thing to pay attention. Okay, let's go. There is, when you talk about the trigger, you can change the level. Okay, for example, we said we are on an edge, and in edge trigger, it would triggers when voltage exceeds a certain threshold or get lower than a certain threshold. That threshold is adjusted by this level, and you can see the value here. Okay, on the top right of your screen. This is the trigger value, the trigger offset value. And there is also a knob here that shows the value of the trigger. Okay, if you click on that, it would reset to 0 if you push that knob. Now, those modes, auto, normal, and single that we talked about, you can change that using this bottom mode too. So if you click on that, you can change from auto to normal to single and again to the auto. Okay, now there is another option here named force. Okay, this force is basically, this force option basically forces an immediate capture. So regardless of what kind of triggering condition you set, you can force an immediate capture of your signal. Okay, it is useful when testing your setup or when you want to see the signal without waiting. Okay, so these are basically the options on our oscilloscope in this specific model of oscilloscope. Normally, all the oscilloscopes share these kind of like parameters and options. So you can use that for your test and your measurement and analysis, and basically measure the values that you have in your circuit.